Alright, in this video we're going to look at an example of length contraction. So it says that we have a 48 meter tall spaceship that appears to be only 25 meters tall when it is traveling vertically in the air. How fast is the spaceship traveling? So I'm going to try to draw a quick spaceship here, and so we'll go like this. I don't know, spaceship. Okay, so I have my spaceship, and in real life this is how tall it is. So real life is L naught. So it is 48 meters tall. But because it is traveling vertically straight up, it appears shorter. So I'll try to draw again the same width, but I'm just going to make it look a little shorter. And so it appears to only have a length, I'll say viewed from Earth, of 25 meters. Alright, so this is our equation for length contraction. L is the length something appears from Earth. L naught is its actual length, and then it is 1 minus, or multiplied by 1 minus v squared over c squared. So this is the length as it appears from Earth, so I'll put a little e there to kind of help me. Alright, so basically the question is, how fast is the spaceship traveling? We have to solve for v. So when you're solving for v, that's just a bunch of algebra mess that we have to contend with here. So I'm going to do a little bit of algebra manipulation before I pick up my calculator here. Alright, so it appears to be 25 meters tall when I know that it's really 48 meters tall. And then I have 1 minus v squared over c squared. And since I'm going to be writing c squared a lot, I'm not going to plug in the value yet. Alright, so to solve for v squared, I'm going to divide both sides by 48. So that's going to give me 25 divided by 48. Whoops, that's a 4. 48. And then that would cancel on this side, and I'd have 1 minus v squared over c squared on this side. Now to get rid of that square root sign, I'm going to square both sides. So we'll do that. So that's going to give me 25 over 48 squared, and then the square root will go away, and I'll have 1 minus v squared over c squared. So the next thing I'm going to do is I'm going to subtract 1 from both sides. So I would have 25 over 48 squared, subtract 1 from both sides. When I subtract 1 from this side, that will go away, and that'll give me a negative v squared over c squared. Alright, so I'm going to pick up my calculator here for a second because I'm just curious what this is over here. So I have 25 divided by 48, and I'm going to square it, squared, and I'm going to subtract 1. Oops, you can't see any of that. Alright, so I get a negative point, so negative 0.7287 blah blah blah. I won't write all that down. And then this is also a negative. So now we'll multiply both sides of the equation by negative 1, and that will get rid of our negative sign. So I have 0.7287, and all of the other stuff that's on my calculator equals v squared over, now this time I'm going to put in the value of 3 times 10 to the 8th squared. And I'm trying to solve for v squared. So again, I'm going to kind of cross multiply. So v squared is going to equal that number on my calculator screen, 0.7287 with all those extra decimal places, times 3 times 10 to the 8th, and then I'll square that. So I have the number on my calculator screen, but I had to get rid of the negative, so we will take the negative of the, whoops, that's going to make a mess. Alright, so there's my number on my calculator screen, times 3 times 10 to the 8th squared gives me that. So that's going to be equal to v squared, so I'll square root that. And I have a big number, but if I move my decimal point over 8, 2.56 times 10 to the 8th meters per second. 2.56 times 10 to the 8th meters per second. And that's how fast the spaceship would be traveling to reduce its height from 48 meters to 25 meters.